Thank you very much, Vinay, for the really lovely introduction, and thanks again for I think the invite. So,
Great. So I've curiously titled my talk "Experiments in Probability" because I really couldn't come up with any better title. But I hope that this does justice to what is to come. As always, as in any outreach talk that I give, just feel free to stop me and ask questions. And I don't intend to complete all that I have planned. So you can always stop me, and it's totally fine even if I don't get to the end of my slides. So as always, again, I have divided my talk into 4 different parts. So even if you're not able to follow one, you'll be able to catch me back up on the rest. So let's begin. So just to give you a quick overview. So what I want to do is just talk about a very simple experiment that almost everybody here should have done, which is simply tossing a coin aimlessly. If there's some beauty behind it, that's what I want to explore first. And secondly, we're going to take a huge change in step, and we're going to talk about how we count tigers in India or in a place, right? And finally, the third major topic that I'm going to touch upon is very relevant in the current situation, given COVID, vaccinations, all these nonsense which is going on, which is how are drug trials conducted. So I'll elaborate much more on that when we get there. And finally, just some random weird problems that I found nice to think. So this will be the structure of my talk. And as always, I don't intend to complete the slides, and stop me if you have any questions. Okay, awesome. So let's just dive into the very first section, which is to find out if a coin is fair or not. Let's see what there is. So what I'd like to do is to begin with an experiment. So Vinay, can you post the first 2 links in the chat? So the one on coin toss experiment and enter coin toss data. So don't use, so for the students out here, don't use the links just yet. So just open the first one, which is this randomservices.org, and I'll tell you what to do from then on. Okay, thanks, Vinay. So you can see in the chat the coin toss experiment. So please open that, and you should end up with a screen like this. Right? Can you confirm if you can see the randomservices.org page?
Yes. You can see.
Awesome. Okay, great. So I don't want you to change any of the parameters. Okay, let whatever is there here, let it be as it is. And all I want you to do is to click on this play button on the top left. Okay, click on this play button once, and let's see what happens. Okay, that's all I want you to do for now. Okay.
So we should write down our observations, what we see.
Yes, you should write down your observations, but I'll tell you where to write. Okay, you don't need to change any of this. Let N and let P be as it is. Okay, don't touch these slider bars at all, because that can.
I got something very interesting. 5 heads in a row.
No, wait.
Nice.
So that leave it to Aniruddhan to share. Yeah.
Okay, so I want all of you to do the experiment. Okay, I want all of you to press play and note down what outcomes you get, maybe in a piece of paper, or maybe I'll tell you where to write. Okay, have a reasonable number of you done the experiment? I'll just wait for a minute or two, and then we can carry on.
You can just show a thumbs up if you have finished doing the experiment, so we can get a sense from there.
Yes.
Awesome. Okay. So as a number of you would have finished, and now again, Vinay, I think I'd like you to post the second link which I sent, which is enter coin toss data. So what I want you to do there is very simple. Okay. So you would have seen a row of head and tails, right? You tossed 10 coins, and you would have seen a row of HT. Some nonsense, right? I want you to enter in the same order. I want you to enter it in this. Okay, don't fight for space. Just leave some space, and then everybody don't enter in the second or the third serial. So randomly enter, maybe like in the 16th or 17th or whatever. We'll deal with empty entries later. Okay, just to give you an example, look at what I got. One tail, 3 heads, 1 tail. Okay, I'll first enter that. Okay. What did I get? 1 tail, 3 heads and 1 tail. And the next thing I got is what? I got tail, head, head, tail, tail. Let me do that. Tail, head, head, tail, tail. Okay. That should be the first 10 columns. Okay. Enter your name and the outcomes. I'll give you some time, and I think there are about 100 people. Okay, so I'll just enlarge the serial numbers then.
Aniruddhan,
Yes.
about 10-15 of them joined just now. So
Sure.
can
I'll
you
just repeat
once again, and then I will share the links once again. And those who have
Definitely.
already started filling it in, you can ignore the messages in the chat. This is for those who joined just now.
Okay, thankfully I'm not able to see the chat, but it's okay. Okay, so what I want all of you to do, for those who have just joined, is I want you to go to this link and you will see a screen like this. Okay, and let me just refresh. Okay, you will see a screen like this as soon as you press the link. And what I want you to do is to not change any of these parameters, but I want you to press this play icon. That's all I want you to do. Okay, don't change, don't slide any of this. That kind of has the potential to mess everything what we're doing, and that shouldn't happen. Okay, so
the link has been posted in the chat, so you can take it from there.
Awesome. So once you do this, you should have some random sequence of heads and tail heads. I'll tell you what we're doing in a minute. Okay. And what I want you to do is you'll also have in the chat a Google Sheet. Okay. I want you to enter whatever you got in the same order in the Google Sheet here. So just take a look. People are already entering, and just do it in the same fashion. Okay, and try not to write over somebody else's entries. So just take some random number between say 60 and 100 and put your entry there. There's a lower chance that you'll coincide with someone. Okay, instead of everybody going and ramming into the first 10 slots.
Yes, I'm getting some messages from participants that my data has been removed and so on. So I would suggest you just go to some row, quite below, because if two people have selected the same row, it's going to be difficult. So, yeah.
So I initially thought of asking everybody to rename their rename and then join in with their quote unquote roll number, but that's just way too much effort for this. So let's just go with this. It's okay. Okay, while you're doing it, let me just tell you what we're doing. Okay, so this is a very simple experiment. You have a single coin. Okay, this P equals 0.5 in some sense is telling you that the coin is fair, which means you have an equal probability that the coin will land in heads or the coin will land in tails. Okay, that means because if you are tossed, I'll not explain it now. So you have an equal probability or fair coin, whatever that means. Okay, and what I want to find out is I want to question this website. Is this coin really fair? Can I find that out? And that is what we intend to do with this experiment. Okay, and I'll tell you why we're taking so many entries, why is each person tossing the coin 10 times. Let's see why we do that. So maybe we'll wait for a minute or two and awesome. So also in the last column of the sheet, maybe you can also fill in how many heads you got, right? In the same sequence, count how many heads you got and fill that in the last column. Okay. In the meantime, I'll be doing it for those who are in. Okay, the more of you do it, if more of you do it, then the better will be the results. So let's see how things go. I see. I'm going to remove. Please try not to spam in this because there's someone whose name is H and seems to have put everything H. I'm not saying it's not possible, but kinda doubtful about that. So
it will actually spoil the fun that you are going to see. So
I'm just going to remove this entry for now, but
I can see 2 adrits.
that's okay. So we'll just wait for a minute or two and let's see how things go after that. Okay, quite a few seem to have filled it, and great.
In the first few, a lot of people have filled.
So I hope most of you, Vinay, will it be a good time to resume?
Yeah, I
or
think
should
you
get
can.
started?
Yeah, you can continue.
Okay, let's do that then. Okay, so this is what you have done, right? You have used this app to toss a coin 10 times virtually, and you have noted your name, the tosses, and the number of heads in the Google Sheet, right? And this is the question we want to answer, which is the coin you tossed fair, right? If you look at this, it says P equals 0.5 here, right? And this is what I want to check, whether P is indeed 0.5. That is what I want to check, right? But the question is, how do I test if it is fair? That I have to come up with some sort of a thought experiment or something where I have to, in some sense, conclude or disagree with the claim that it is false. Johan, question?
No, I think I have a way of finding if the coin is fair.
Oh, sure, shoot. What is it?
At the end of the Google Sheets, we have written how many heads we got in all of the outcomes, right?
Correct.
So maybe if we take the average of that, and if it's 5 or something similar, it might be fair.
Awesome. Let's do that. Okay, so let me just do the same thing what you said. Okay, I'll first find the sum, and let's see. Oh, I also have to find out how many people there are, which is kind of tricky. How do I do that? Any ideas?
You can use the average thing. Just there is a function called average.
No, you
Average
cannot.
doesn't
AVG.
zeros, I hope.
No,
You can't do that. The blank spaces are considered.
Yes,
Oh,
so
that's unfortunate. Oh, not bad, not bad. I think blank spaces are not considered here. Okay, if I put in a 0, the average should reduce. Okay, no, blank spaces are not considered. Awesome. Right? So, okay, does someone else want to take it from here? I got a 4.89. Is it close enough to 5?
Yeah, it feels clear.
that's close.
Close enough to 5, right? Now
Very
can
close.
someone tell me why this
Oh.
works? Very close to it,
Definitely
right? And you have to agree, there is no rigging here. I did not tell you that you have to put a head, you have to put a tail. There was no rigging here, right? I did not know any of you beforehand, most of you rather, right? So now can someone volunteer to explain what is going on in this experiment according to you? So maybe, yeah, I see Anushka.
Sorry, sir, could you repeat? I couldn't hear what you said.
No, so my question is, so you see the average here is surprisingly close to 5, right? And let's see why 5 and everything, but why is this nice? Why am I happy with the outcome of the experiment? Any guesses?
Okay, so I feel that we are happy with this 5 because the middle value of the middle value is
The middle value is
like 5. So
good.
if the number
Good.
is quite close to 5, we are happy because then with this we can say that it is quite fair. But still, if we have less number of observations or it's still, I don't agree it's fair.
Okay, you don't agree, it's fair. Okay, so I see Sai Arun Prasad with a curiously raised hand. Let's see, Sai Arun Prasad.
Yeah, sir. So now the number of heads is what we are taking the average of. And now we have seen is disturbingly close to 5. And the total number of things we have gotten, total number of outcomes we have taken is 10. In 10, when you take the probability, you get 5 heads up. Approximate probability is 5 out of 10, which is a half, meaning it's actually having a fair probability.
Awesome. That's a great answer. And maybe one last person, Kirti. And there are many more experiments to come. So I'll let all of you do the talking later. Okay. Yeah. Kirti.
So in 10 outcomes, it's nearly 5 outcomes is what we get as heads.
Right.
So half is head and half is tail. So it's 50-50%. And I had
Awesome.
another doubt. Do we consider that the
Okay.
coin is standing like this or anything? Or is it only heads and tails?
There's no Sholay. There's no Sholay coin, don't worry. So if you don't know what Sholay coin is, then there are plenty of clips available on YouTube. You can check that out. Okay, the coin doesn't stand on its side. It always falls heads or tails. That's our assumption. Okay, but now I have a question for you all. Right. So the average turns out to be 4.89. But if I see the entries, so there is a 3 here. I somewhere saw there's a 10 here, surprisingly, and there's a 1 here, and there is another 1 here. So there are small numbers as well as there are large numbers, right? So is there a way that I can make sense out of this? That is, there is someone in the audience who has got 10 heads in a row, or there's someone in the audience who has got just 1 head and 9 tails. Right? Doesn't that kind of seem weird?
Sir,
So,
I got 10 heads.
Oh, awesome. That is great. You got 10 heads. That is great. Right. So it is still possible, right? Even though we think that there's something which so if I were to ask you to write a random sequence of heads and tails, will you ever write 10 heads in a row?
No.
Mentality, no.
Never. Right? How come the coin tossing experiment is doing this? Right. So this in fact gives you a very nice takeaway, which is your brains are not random. Right? The numbers you produce if I ask you to give you a number randomly, you're not going to give a random number. Right? So this field of random numbers and random number generators, though I don't know too much about it, is in fact a very vast field. Right? So there's just a very small taste of what happens in random. Now let's try to understand the experiment a little bit further. Right?
Actually, request, can anyone please share the links again? I had gotten disconnected.
Sure. Vinay, can you share the link to this?
Like
Yeah, but then just this document link, or I mean, because you're not going back to this right now, right? I mean, you're going to proceed with the talk. So
yes, I'll share my screen anyway, so I think it should be fine. Maybe the subsequent experiments you could share. Yeah. Okay. Awesome. So we had, let's say, about maybe I would guess around say 70 people entering their names in the chat, right? Sorry, in the Google Sheet, and each of you did 10 experiments, right? And so how many experiments does that count? 70 into 10, that is 700.
700.
The coin was tossed. Now, out of these 700, how many of them fell heads? That's what I want to find out, right? So let me just try sum of, let's do this. I want the sum of, why is this here? I'll put a 6 here randomly. Just give me a minute. What I want to do here is just the sum of everything so far that we have seen. Right? Out of these 700 experiments, about 295, not bad, came out to be heads. And that's what I want to understand. Right? So think of these 700 tosses as written in a line. Right? There's a first toss, there's a second toss, there's a third toss, and so on. There's a 700th toss. Right? Let me call each thing as xi. Right? So what I will do is, if the first toss is a head, like I can in some sense order it, right? So I'll call it 1, 2, 3, 4, 5, and so on. Then 11, 12, 13, 14, and so on. 21, 22, 23, and so on. And ultimately ending up at something like 690, something 697, 698, 699, and 700. Correct? I'll stop there. Right? So what I will do is I'll call it, I'll put x1 to be 1 if it is a head and 0 if it is a tail. So let's see, what is my x1? My x1 is going to be a 0. My x2 is going to be a 1. My x3 is going to be a 1. My x4 is going to be a 1. My x5 is a 0. Okay, is that clear? So can you tell me what x8 is? Is it a 1 or a 0? If I understood the experiment. 1. Awesome. And what is x10 going to be? This is my x10.
0.
0.
Awesome. Okay. So you have understood what these x1, x2, x3 nonsense are, correct? So that is what I'm doing. And now, can someone tell me what, according to the website, is the probability of xi being a 1?
Half.
0.5
Both being 1 by 2.
Half.
0.5 are half and half, right? The website is claiming that the coin is fair, right? Finally, now what is the total number of heads? The total number of heads is simply this, right? Are you convince yourself that the total number of heads in n tosses is in fact x1 plus x2 plus all the way up to xn? Why is this true? Can someone explain why is this true?
So because the x values, when if it is a head, it is 1, and if it is not a head, it's 0. So if you're
Fantastic.
counting the number of heads, each head has a value of 1, and if you add them all together, still it's gonna be this number.
Awesome. That is great, right? When I'm adding something wherein I got a tail, I'm not going to add that at all. Whereas when I'm getting a head and I'm adding something, then I'm going to add a 1, right? So heads n simply counts the number of heads in these 700 tosses. Okay. Now, what is the number of tails? The number of tails is simply the total number of tosses minus the number of heads you got, right? Here in my case, n is around 700. Okay. The number of tails is simply the number of zeros I got, right? So that is just going to be the number of tails n minus hn. Okay. Now, what I am interested in is what we were interested in last time is what the average is, correct? This is what we were interested in, which is the proportion of heads in n toss. That is what we wanted to find, right? So if there are say hn heads, I want to find out hn divided by n. That is how many heads are there per toss in some sense, right? So that's not a nice way to say this, but in some sense, what this is saying is like on average, how many heads are you getting in these 700 tosses? Okay. Now, what according to you should Pn be? What would be your guess for Pn?
205.
Or somewhere close. Somewhere close to half.
Somewhere close to half. Okay. What would your guess for say Hn be?
Hn would be approximately
Half of
290.
And
Half of no.
292.
n by 2.
N by
yeah,
two.
n by 2. Yeah.
5.
And what is Tn going to be?
N by 2.
Again n by 2.
Fantastic. Right. So you have helped me with my next slide. Right. So what we want to find out if the coin is really fair or not. Right. So we want that the number of heads is n by 2 and the number of the proportion, that is Pn. Remember, Pn is simply Hn divided by n. Right. We want this Pn to be 1 by 2. Right. But for this, I want my n to be large. Right. Here we have plenty of people, 109 people in the audience. Right. 70 of you or 80 of you would have entered in the chat, entered in the Google Sheet. Right. And each of you entered it 10 times. My n is somewhere around 750 or 800, which is a very large number. Right. So I don't quite have a problem with what my n is here. Right. But clearly it doesn't work for just one toss. Right. For example, if I toss a coin and it comes out head, then my Pn is going to be 1. Right. My H1 is also going to be 1, which is one and a half very different. Right. So for one toss it doesn't work. But as I increase my what is called the sample size, right? As I increase my sample size, my number of experiments, as I increase, what I expect is going to become truer and truer, right? That is what is going on here, right? And this is a milestone result in probability theory. It's called the law of large numbers. You'll see a very nice, there's a very beautiful proof of this, which we'll not get into, but this is a really very famous result, and it has applications left and right, as you'll see in a minute, right? So any questions at this point? I see one raised hand, Dikshant.
No, sir. I actually wanted to explain that time and forgot to look.
Okay, is it clear now? Or?
Yes, sir.
Okay, awesome. Okay, so if no questions, then we'll continue. Right. So what the law of large numbers actually says is that in most cases, Pn, which is the proportion of heads in n tosses, actually goes to half. Right. So why am I saying in most cases? Because this experiment could have failed terribly. Right. Maybe so as one person got all heads. Right. Similarly, all of you could have got all heads. There is nothing stopping that's nothing stopping it. Right. it's still possible that all of you got all heads, right? So this experiment could have failed terribly, but randomness ensures that it really doesn't fail, right? So this was, in some sense, a very successful experiment. So I'm happy with the result. I got 4.89, which is close enough to 5, right? So as I increase my sample size, right, say 200 people enter, and let's say we do 2,000 tosses, right? Then your proportion will get closer and closer and closer to 5, right? So this is one of the major consequences, called law of large numbers, right? Now, okay, any questions at this point? Anyone?
No.
Okay, awesome. That's great. Okay, I think there are a couple of questions in the chat. I seem to have missed them. If we have 9 tails and 1 head outcomes, then in that time also we have 50% of. Oh, so if we have 9 tails and 1 head, that's an interesting phenomenon. Okay, let's see here. Okay, so for example, this person here, Tanish, right? They got 9 tails and awesome, 9 tails and 1 head, right? So what randomness is telling you is that it's not guaranteeing that you'll get 5 heads and 5 tails in every single experiment of yours. What it is saying is that on an average, you'll see somewhere around 5 heads and 5 tails. Let's, for example, when I toss a coin twice, I'm not telling you that one will be head and one will be tail, right? If you toss a coin, say 20,000 times, on average, I'll expect 10,000 heads and 10,000 tails, roughly around. There'll be some plus or minus, but that is roughly how much I would expect. Okay. Awesome, right? So that's great, and I think I haven't missed any other chat question. Okay, great. So let's move on to another experiment, but this time it is an exercise for you. Okay, so I'll just quickly summarize. Yeah, question.
Sir, can you please explain once more why this cannot happen for where number of experiments is 1?
Oh, okay. So let's say, for example, I have only 1 toss. I have tossed the coin only 1 time. Okay. So I'm either going to get a head or I'm going to get a tail. Correct. I can't get half a head and half a tail. Right. But you're claiming that the coin is fair. Right. That means what? Half of the heads, half of the tosses should be head, and half of the tosses should be tail. Correct. But I'm doing only 1 toss. Right, that means half of the toss should be a head and half of the toss should be a tail, which doesn't make sense. Right? So you want a large number of tosses for you to experimentally verify this experiment. And that is exactly what we have done. Okay.
Okay, sir.
Awesome. Nice. So now, okay, I'll just quickly summarize what we have done so far. So we tossed a coin 10 times. You all entered your name and details in the sheet, the tosses in the sheet. And what we wanted to find out if the coin was really fair, right? And so we did a whole bunch of equations, right? So even though unnecessary, but this is something to get a hang of what we are doing. Right? We said xi was 1 if the toss is a head and 0 if it is a tail, and hn, which is the number of heads, is simply the summation of all these xi's. And the proportion of heads is simply hn divided by n. And what we wanted was this pn to go to half and hn to go to n by 2. And it is, in our case, the result is experimentally verified, right? So we're happy with what happened. Right? Now what I want you to do is an exercise, right? So this is not something we'll answer right now, but I want you to do this at home and tell me what happens. Okay. Now imagine instead of tossing a coin, you're rolling a die. Okay. So a die has 6 faces, right? 1 and 6 are in the opposite, 2 and 5 are in the opposite, and 3 and 4 in the opposite, right? So when you roll a die at random, you will get one of the faces on the top, right? And this is precisely what is being noted here. Vinay, at this point, if you could share the third link, it would be nice. Die is singular and dice is plural, as far as I know. So, yeah. Okay. So, awesome. So I think Vinay, awesome. Great. So use the die roll experiment, which is the third link, and there you should see something like this. Okay. So once you click on that, you'll have you'll have a random, quote unquote, random sequence of 5 rolls, right? So there's a 6, there's a 4, there's a 3, there's a 5, and a 6, right? And now what I want you to do is something which is very similar to what we did. I want you to enter these in the Google Sheet here. And Vinay, at this point, the fourth link. Awesome, thank you. So enter the dice rolled data in the fourth Google Sheet that you have here. Okay, and as always, use the later part. And oh, I just saw someone write over someone. So please try not to do that. Though I know that you won't be able to figure out, but use the later part.
Oh, it's lagging. I think that's why.
Yeah, that's okay. So just pick some number. So there are quite a few rows. So you can, but don't go too much below. So maybe try to keep it within 200. And I would notice if you wrote it in like some column row 7,000. And just to repeat, so you'll see two links in the chat. This is the first link you'll see in the chat. And when you click the link, you'll see something like this. What I want you to do is to roll the dice, and you'll get some random sequence of 5 rolls, right? And what I want you to do is simply note these. So this is 5, this is 6, this is 2, this is 4, and this is 6 again, right? What I want you to do is to note down these in the Google Sheet here. Okay, just write that down here. So maybe we'll wait for maybe 2 more minutes and we'll.
I wrote 1 2 2 1 4, not 1 2 2 2 4.
Ah,
oh
okay.
yeah.
I prefer to write your name so that I know that there's no spam inside here. Not that there's any way for me to verify, but still. So I think a good decent number of you have entered it in the Google Sheet. So let me continue. Or should I give a minute more, Vinay? What are your thoughts?
Yeah, but not more than that.
Okay.
But everyone's overwriting. My details got erased 4 times.
So just put it in some row. So like some.
I went randomly. I went down also. Still someone erased it.
Don't be, yeah. Others don't do that. No, you're better than a kindergarten kid. So.
Oh, nice, David. I like that.
So somebody also overwrote mine. I was in row 5 and row 6.
Sir, I'm not sure.
I was in row 23 and I just changed
All right.
my.
Aniruddhan, let's see whatever we can do with the existing data.
Sir, in the 57th row, I've put 2 as the last outcome, but for some reason it hasn't changed. It hasn't changed it.
My dice, I'm getting 1, 2, and 3.
Yeah, 2 is the last one. I think someone overwrote mine, the last outcome.
Highly possible.
So someone
it's okay.
overwrote me.
It's okay. So it's okay when if there has been some overwriting, but nevertheless, I think let's just take write it in the later entries and we can see it. Okay. Awesome. So it's okay. Don't worry if you've been overwritten and things like that. It shouldn't be too much of a problem, right? And this anyways an exercise for you. So as usual, you've done this, right? Now what I want you to do is to carry out an analysis similar to what you did in the dice, in the coin toss case. So can someone detail out what you will be doing? What do you think you should be doing in this case?
So we should be predicting the out. We should do the exact same thing as before, finding averages.
Finding averages of what?
But hold on.
All the outcomes.
Yeah, every outcome.
Okay.
So the number of
we should find the number of outcomes of one specific result.
Awesome,
Or you
awesome.
you can just toss everything and find the outcomes.
Yes, okay.
We should find how many times each number appeared.
Fantastic, fantastic. That is what I was looking for, right? You have to count how many times each number appears. You cannot simply take the average. Right? In the last experiment, you had only two outcomes, right? It's either going to be a head or a tail. But here you have 6 different outcomes, right? 1, 2, 3, 4, 5, and 6. You have 6 different outcomes. So what you should do now is to count among these whatever entries, say 700 entries, you have to count how many ones there are, how many twos there are, how many threes there are, how many fours, how many fives, how many sixes. Right? You have to count
You can
all
get
of
for
them.
free.
Sir, in cell 72, I've made a very interesting observation.
Okay, which is?
Somebody's deleted my thing again.
Is that the interesting observation?
What was
Yeah.
Hopefully not. What was your observation? I hope you had something better to say than somebody
No,
deleted.
72, it's still that. 72,
What
it's
is?
still that. 24542.
Nice. So it's quote unquote palindromic. Is that your observation?
So in my observation, it's not at all fair. It came 6, 2, 2, 2, 2.
Yeah, maybe. Possible.
I got
Two,
near
two, 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 two,
palindrome except the last 2 digits were
nice.
Yeah.
There are all sorts of nice.
It's like that.
My first 3 and the last 2 are palindromes.
Nice. That's good. That's good. So there are all sorts of nice things that can happen. That's awesome. Right. So now what I want you to do is do something which I'm not sure who, but they suggested. Right, which is you have to count the number of ones, count the number of twos, count the number of
Yeah, but
threes,
how do we count the number of twos?
Oh, it's painful.
Manually?
Yes, it's painful. That's one reason I did not do it.
No, you just do Control plus G and it will
you can
find
do
all
that.
the
In the
tools for
Excel, you can do it. But
That's a
then
nice way to do it. Yes, you could do that.
You
So
use
I'll do
count
one
if.
thing.
Sir, do Control G.
There are
Control G.
53.
So, yes.
There are like
So now what I
53
will
twos.
do-
50 ones, 54 twos, 55 threes, 73 fours.
Just give me a minute. So in a while, what I will do is I'll edit
Just
the Google
do
sheet.
a Control G,
And-
sir.
Yeah, that is great. So in a while, what I will do is I will edit the Google sheet and also give you the number of ones, number of twos, and you can carry out your analysis from then on.
By the way, the number of fours is extremely high. It's higher than all the rest.
Unfortunate.
Yes,
but
sir.
it's possible.
Sir, yeah, you can just do Control F, and then when we type in the number, we have to subtract 1.
Control G.
Yes,
We can.
there are all sorts of suggestions. Thank you, but yes, you can do them. Okay, so let's set it.
Numbers will
Move
be
on
similar
to
to each other because you don't have any rules like they should not repeat once or like.
Yeah, but in the end, we have to subtract 1 because we are also calculating that one of the column number outcome 1, outcome 2, outcome 3. So after doing that, we get the number of ones to be 49. The number.
Okay, that's okay. Numbers don't matter. It's okay. Numbers you can you can do it for yourself. Okay. So yeah, Kirti, I see a raised hand.
Yeah, so I think each number should be like about 1/6 of the total number of entries.
Fantastic. Each number should hopefully be 1/6.
Yeah,
But let's see what
like,
happens.
It's like more or less about 1/6 of the total number.
Hopefully so. Let's see what happens. So that's for you to figure out. Okay, awesome. Right. This was the first. So now, we did 2 experiments, right? One is tossing a coin, and the other is rolling a die. Right, some 700 times we did that. Right, and we noted something very interesting result, which is called the law of large numbers. Right, we noted a very interesting result. And now let's see what are its real applications. So that's one question that we want to see. Right. So, thankfully I mentioned a non-Sholay coin here. So if you see Sholay, I haven't seen Sholay, but I've heard that the coin lands on its side. So if you take a non-Sholay coin, and so you can use a similar result to decide if the coin is fair. Correct. So
What is a non-Sholay coin? What is a non-Sholay
it's
coin?
just a regular coin. The coin doesn't land on its side. It's either going to be a head or it's going to be a tail.
Okay.
Okay.
Sorry,
Where can I
Sholay
buy
is the name
Sholay
of
coins?
no, Sholay is the name of a movie. You will not find any. You go to a shop and then you ask them non-Sholay coin. They will not give you. It's just a
Could I have
cooked
some
up name.
Sholay coins then? Because I really want coins that land on this side.
You could make one. Let's try making one with cardboard, and you could try doing
A
that.
Sholay coin
As
has
if-
both heads.
Yes. Okay, maybe. Oh, I don't. Okay. Anyway,
Biased.
we're assuming it's a fair coin. Okay. Okay. So what I want to do is want to decide if the coin is fair. And what is the way I did that? So that's precisely what I did, right? I ran the experiment 700 times. Around 350 of them came heads, around 350 of them came tails. And I was happy to conclude that the coin is most likely fair. Now, can someone tell me a stronger experiment that we can do? Maybe put it out in the chat to avoid too much intervention. Maybe just put it up in the chat. Just I'm expecting a one-line answer using a very similar procedure to what we did. Can you do something which is better? Not just about finding if the coin is fair or not, but you could chat. If the chat is disabled, it's okay. I think it's good in one way. A direct message too. I think direct message you can. Yeah. Okay, you can chat. Okay, great. Either way is fine. Use a known coin as a bias control. No, I'm not asking how to improve. I'm just asking, is there something that is nice that you can say about a given coin? So one thing I can say is if the coin is fair or not, right? If I'm given a weird coin, can I do something which is better? Any guesses?
So your voice is not clear. Like, what are we supposed to find out?
Okay, is it better now? Is my voice okay now?
It's
Sir,
clear,
what
Aniruddhan.
Sir, what if we get a very, sensitive sort of weighing balance?
Okay.
We get a very sensitive sort of weighing balance, and then take a non-Sholay coin,
okay,
and also compare it with the Sholay coin.
Okay, and what would be the conclusion of that?
We would see that the non-Sholay coin is very by a small difference lighter than the Sholay coin.
Okay, so that's still going around the lines of is the coin fair or not, right? But I want to do something better.
So I have something better. I have something a little different.
Okay,
You can take a beam balance. It's a little similar
forget
to
about
what
weighing the coin. Forget about weighing the coin.
but no, a little different. No, you can determine whether you have a coin and whether it's not a normal coin, if it's a 4 coin.
Yes. Okay.
Now, some coins are heavier or some coins are lighter than normal coins. When you're going in a beam balance and weighing them, the 4 coins will actually be more heavy.
Okay.
Maybe that can affect its probability of hitting anything.
Good. Okay. A lot of interesting suggestions in the chat. And I particularly like one answer, which is Tane Nasikar. I hope I'm pronouncing your name right. But they say we can determine the probability of getting a head or a tail. That's a fantastic answer, right? Can if you're here, Tane, can you elaborate how you do that?
So what was his answer? Sorry, I couldn't hear you properly.
So Tane's answer was, give me a minute, I have to scroll back. Okay, so Tane's answer was we can determine the probability of getting a head or a tail. That is, I'm given a random coin and I'm not just interested in finding out if it is fair, but I want to find out what is the probability that it will land head? What is the probability that it will land tail? Right, and that's what Tane claims that this experiment could answer. If Tane, are you here?
Yes, sir.
Hi. Yeah. Would you want to explain how that would be possible?
Sir, if you calculate all the heads and divide by the total number of trials, then you will be able to determine whether the probability whether the next toss will be a head or a tail.
Amazing. Next toss will be a head or a tail. No, I have to catch you there. How?
No, but that would be like the probability that you will get heads, right?
Correct.
Like if you take a fair coin and all of them are heads, that doesn't mean the next one will actually be a tail.
Yeah.
You'll just get a sort of overview.
Yeah. So
And then
that-
there
so-
will be a high probability that it will be a tail, but not exactly sure.
No, if you know it's a fair coin, then it's always 50-50, no matter what the previous results are.
Good.
Yeah,
That's a nice
exactly.
answer. That's a
So the
nice answer.
probability of taking the probability of having like, I don't know, 15 continuous tails is very low.
Okay, okay, keep that statement in mind, and I want you to answer a slide which will come up later in the talk. Okay, Sai Arun Prasad, I remember the name. Okay, so what there's almost the second last slide I have planned. So not this, but what I plan to do then. Okay, so in fact, so a part of just give me 1 minute. So a part of Tanya's answer, in fact, answered what I wanted to ask, which is I'll run the experiment 100 times. Right, I'm given a weird coin, and I want to find out what is the probability of it landing a head or what is the probability of it landing a tail. I'll run the experiment, say 20,000 times, right? I'll toss the coin 20,000 times. And let's say it lands heads only in maybe 200 of these, right? 200 out of 20,000. Then what I will say is that the probability of getting a head is just 200 over 20,000, which is a 0.01. That is, it is very tail heavy, right? So this is one very interesting experiment which you get. Right. So another interesting experiment that we can do is what is called an opinion poll. Right. So the idea is this. Let's say I want to find out. So there are elections coming up. Right. The elections are going on in some states, and I want to find out who will win. Right. That is of very much that's of a lot of interest. Right. Who is going to win in the election?
Sir, you can do an exit poll, sir.
Yes, that is exactly what I'm getting at. Right. And so what you can do is, instead of asking everybody who they voted for, I don't know. I mean, I'll anyways know the results on the counting day, but I want to know what the mood of the nation is before, right? Before the polls itself, I want to kind of have a sense of how people are feeling towards a political party, right? So
you can carry out a survey.
Yes, I'm coming there. So instead of asking everybody what they're going to vote for, who they're going to vote for, that's like conducting the election all over again. Right? Instead of doing that, what I will instead do is simply select a random collection of people and ask them whom they're going to vote for. And
it's like a sample.
Based on that, I'm going to make a prediction.
Right, like what will you do if that same survey is done in a particular area where only it favors only one particular party?
You'll have to pick the people randomly.
Yes, this is the beauty.
For the more randomness, more accuracy in the exit polls.
I love that answer. Yes, the more randomness you have, the more will be the accuracy. Right? You have to pick your sample as random as possible. There shouldn't be any bias, whatever that means. Right? So this is one opinion poll, and there's something called the infinite monkey theorem. I'm not going to elaborate on this, but that is for you to read after this session. Okay, check out this thing called the infinite monkey theorem on Wikipedia. A rather funny name, but it's a really nice thing. Yeah, Kirti, I see this hand. No.
Yes. How can we determine whether the number of samples we are taking is enough or not?
Fantastic question. So there's something called an accuracy which you need. So for example, here we got something like 4.89 out of 5, right? The coin tossing example, if you recall. Now, if I say that no, I don't want 4.89, I want something above 4.95, otherwise it's flawed. Right? If I get the average is 4.95 or above, then I'd say the coin is fair, otherwise it's false. Right? So based on how much my accuracy is, I'll decide my sample size. Right? So here I didn't set any accuracy. So anything say plus or minus 0.5, you would have accepted it. Right? But let's say if I told you that I need either between 4.95 and 5.05, the average, then based on that, I'll decide the sample size. So there is a simple combinatorial thing that you can do. Right? So there is something, it's not very difficult to do that. Okay. But the sample size is going to depend on how much accuracy you want. Okay, so the higher the accuracy, obviously, the higher the sample size. Okay, that's a fantastic question. Awesome. So now let's come to something which is slightly. So this is the end of the section. So we'll move on to something more or less unrelated, right? But on similar lines. Okay, as usual, I'm not doing that well on time, but it's okay. We'll skip one of these sections. Okay.
So now what I want to do is something even more interesting, right? I'm done with coin tossing and dice flipping, right? Now what I want to do is I want to count how many tigers there are. Okay, let's not think about something as big as India, but let's just say in a particular sanctuary or things like that, in a rather restricted area. Okay, and these are questions that biologists may be interested in. What is the population of a surviving species, right? That is something which I'm really interested in. And but because of these various constraints, it will take too much time to count these tigers one by one, and it's scary too, obviously, right? And you need too many people to, in fact, go and count them. It's not a cheap task to count every single animal, right?
And
Sir,
also
we can
they
carry
move.
out animal census.
Yes, animal census is one thing, right? But let's say I'm not interested in the entire exact number. I don't want to know that there are 8,312 tigers. I don't want to know about how many numbers to the digit.
So you don't have to like do that. If you just
I'll
count it the first time, and if you like calculate the birth rate and death rate of the tigers, the next year you can simply just using that you can count the.
But again, for birth rate, death rate, there is a lot of data that you need to maintain, right? That is one. And so for that also you should have had an accurate counting of all the tigers there are, right? Let's say there is a flaw in the first counting that you did,
Sir,
right? If
for
there's a-
for birth rate and death rate, sir.
But you
So maybe you could
Sir,
put
for
trackers
birth
on the
rate and
tigers.
death rate, we have to keep a constant look on the tigers, sir. That is not that much possible.
okay, that's fine.
Sir, I have
So
another
we can put
idea.
trackers
How
on the
will we?
tigers.
Okay, sure.
Maybe you can keep a record of all the tigers in the national park regions, and
That is
you don't.
good answer.
But you
Good
don't.
answer.
But the disadvantage only is you don't know if the tigers exist in the wild or not. Yeah, like in the
Sir,
sense
I
that you
have
don't.
another idea.
There are quite a few. Yeah,
Sir,
Aniruddhan,
in that limited region, first we need to find an area which has a mean, which provides the mean situation
no,
for
that's not
tigers to
happening.
thrive. That is
Finding
not
out the
very good,
mean
not very
situation is
bad.
not happening. No.
No, ma'am, the
I'll tell
only
you
the region where.
why.
Aniruddhan,
Okay,
you went on
yeah.
mute. Can you just unmute and yeah?
Sure. So I'll tell you why it's not a good idea. But so the whole point is I do not want to carry out an extensive survey, right? I'm not interested in finding out how many to the exact number, right? Let's say 8,312 tigers in India there. I'm not interested in the exact number, but I'll be happy with if I say somewhere between 7,000 and 9,000 tigers. I'm happy enough with that, right? So I don't want an exact number, but I want an estimate, right? In some sense, what I want to do is I want to trade efficiency for accuracy. I don't want to be too accurate, but I'm willing to give up some amount of I'm willing to give up some amount of accuracy for the sake of being slightly more efficient, right? Clearly, not counting all tigers is more efficient, right? So this is what we do. And what we have to do is we have to do this, right? Let's see. We all are thinkers. We have to think how to do this. So we have to come up with a strategy to count the number of tigers, right? And the whole idea is this really beautiful technique called the capture recapture method, right? So as the name suggests, you may be able to kind of think of what will go on, but nevertheless, let me elaborate. Right? So let capital N be the number of tigers. Okay, maybe it may not be India, but let's say some particular sanctuary. So someone suggested in Jim Corbett, right? So let's say the number of tigers in that particular. Hopefully, the sanctuary knows how many tigers there are, but in a sufficiently large wild place. Let's see, we want to count how many tigers there are. Right, our goal is not to count or find N, but to estimate N. I don't want the exact value of N. Okay. Now, what I am going to do now is I just go and simply find out 200 tigers. Okay, I'll just go to the wild and I'll go tag them. That is, maybe let's say I'll put a collar around the tiger, or maybe I'll do something, right? Without harming the tiger, obviously. I'll do something to the tiger and let it loose in the wild again. Okay, I'm going to do this for 200 tigers, right? Now, a month or so later, why am I waiting for a month? Because I want these tigers to intermingle among themselves in the wild, right? I don't want the case that let's say I identified all the 200 tigers in a particular point, I don't want to count the same thing again, right? So I'll allow these 1 month or so for these tigers to spread again into the wild, right? But now what I will do is I'm going to identify these 100 tigers separately. I'm going to count another 100 tigers. Okay. I'm going to again go find out where the 100, again going to find out 100 tigers. Okay. This time I'm not going to tag or do anything, but instead what I'm going to do is I'm going to only count how many of them were tagged earlier. Remember there were 200 tigers tagged earlier. Now, when I go again, I'm only going to count how many of these 100 tigers were tagged, right? Now, this is the magic portion, right? The next slide, what is to come is the magic portion. What I claim is that I can find out the value of n, or I can estimate the value of n using this very simple equation, right? That is, the number of tagged tigers out of 100 tigers is 200 by the total number of tigers, right? This is something which I wasn't convinced the first time I looked at it, right? But this is something which will take, at least for me, it took quite a bit of time to completely make sense out of this. But this is something which is extensively used, called the capture-recapture method. So there are plenty of video resources available in this. So if you're still confused, you can definitely take it up. But let's see a slight explanation to this. I won't be able to do complete justice, but let's hopefully try and answer what's going on, right? So what I claim, so remember again, n is what I want to find out, right? The total number of tigers in India. What I'm doing is I'm finding out 200 tigers and I'm tagging them. That is, I'm giving them a collar, let's say. And after a month, I'm going and finding out 100 tigers. And what I claim is that this t by 100 is going to be t by 100 is going to be approximately equal to 200 by n, right? So the reason this works is that the proportion of tigers in the second sample, that is when I went and sampled 100 tigers, right? It should be more or less the same as the number of tigers in the population. So what is going on here is I have this sample of 100 people, 100 tigers, correct? Now among these 100, how many did I already tag, right? So that t over 100 should be equal to how many of my initial samples population. That is, how many tigers did I find? This 200 over n, right? That is my that's my whole idea here. But this is something which which will take some time to digest. So this stare at this for a while, and you should be able to make sense out of this. This is not entirely clear immediately, right? So what I essentially want is the proportion of tigers in the second sample, which is how many tagged tigers there already were in my sample of 100, which I did for the second time. And that should be equal to the number of tagged tigers, which is when I initially set out and tried to hunt tigers, I found 200 of them, right? These 200 I chose out of the n tigers. N is the number I want to find out, right? So essentially, this is the equation. So n is coming out to be roughly 2000 over t, right? But there are plenty of disadvantages to this. So what I wanted to do is maybe put out in the chat why maybe some disadvantages to this method that you can think of. Just put out your questions, maybe put out your questions also in the chat. Maybe slightly easier to manage that way. And so in fact, this method has been in use as early as 1896. And so it was not used for counting tigers, but rather counting the number of fish in an area, right? So in some ocean, I don't remember the entire exact details, but counting the population of a species of fish called pace. So this is a method which was actually used there, right? Okay, awesome. So, and this is in fact used in real life also to estimate how many illegal drug addicts there are, how many people are infected with HIV and all these things, right? So you can think of how to modify the experiment slightly to come up with such results, right? But now I have many more questions for you to think about, right? We sampled twice, right? The first time we sampled, we got 200 tigers and collared them, right? And the second time we went, we counted how many of these 100 tigers were collared in my initial run. Right now, what if I go for the third? What if I go for the fourth time? Will it in any way increase my accuracy? And what should I do in the second time? What should I do in the third time? So these are questions that I can think about, right? So, and is there any interesting analysis to this? Right, that is another thing that you should think of, right? So these are again just questions that that arise very naturally, right? But now what I want you to answer is, what are the disadvantages of that? Is there any disadvantage that you can think of? Okay. Oh, amazing answers in the chat. Okay. Oh, so behind Shah says this is only for a small area. So indirectly, you're trying to say that tigers are evenly distributed equally in India, which is not true. Absolutely, Vihan. So I'm not doing it for entirety of India, right? There's one reason I said take it up in a quote unquote smaller sanctuary or something like that, right? Because tigers are not, hopefully don't roam around free in throughout your streets and houses, right? That would be scary, right? Awesome. So the region shouldn't be large. Fantastic. Vikshant has also pointed out the same thing. And oh, Omkar has an amazing answer. So Omkar, can you elaborate what you mean by your answer? So Omkar says your sample size must be properly picked. Vinay, could you allow maybe Omkar to unmute?
Yeah.
Awesome. Thank you.
Like if you tag a very little number of tigers, then that may be a problem, because then in your sample size there will be no tag tigers.
Fantastic answer, right? So in fact, what is happening here? If I'm upper bounding, right? I'm saying that there are not more than 20,000 tigers, right? So to do this method, my primary disadvantage is that I first have to have a rough idea of how many tigers there are, right? So this n is always going to be less than 20,000, right? If I manage to find at least one tagged tiger in my second population, then I'm certain to get my n is less than 20,000. So I have to choose my 200 and 100 very, very carefully, right? I can't do 200 and 100 for, I don't know, maybe estimating the number of humans in an area, because they're everywhere, right? There are so many of them. Okay, so that's a fantastic answer, right? Awesome. Yes, and this all relies on the assumption that tigers will evenly mingle and breed across an area, which is, I wouldn't call it extremely unlikely, but that's the one of the reasons why I'm letting the collars sink in for a month, right? And breeding is not quite the problem we're trying to address. So it's just at a given stage of time how many tigers there are. So it's okay if the tigers have cubs in the meantime. Yeah, and if t equals 0, n equals infinity. Yes, that is correct. Yes, and awesome. That is good. Nice. So let's see. So this is the whole idea of the capture recapture method, right? So there's something which is very interesting, and you definitely should look up. And I think in the interest of time, what I will do, if I have time, maybe I'll come back to the structurals. But in the interest of time, I'd jump to this section. Okay, so some fun problem. Let's try to figure them out. And now I want you, I think Sayaran Prasad was your name. Now I want you, in a minute, maybe explain this meme. I know this kills all the fun. Explaining a meme kills all the fun, but I want you to do it.
Sir, can you hear me?
Yes, I can. Maybe just wait for a minute or two and let people think about it, and then maybe you can explain. So hopefully I finish in time and have some time for questions. Vinay, I have until 6, right?
Yes.
Okay. I'll stick to my time limit. Yeah. So okay. So I see nice quite a few raised hands, but maybe I'll pick one or two of you after. What was their name again? Sayaran?
Sai.
Sayaran.
Yeah.
Sai. Okay. Are you here?
Sir?
Yeah.
Yes, sir, could you repeat the question again?
Yeah, so can you explain this? It's very much related to an answer you had said earlier. Any idea?
Yeah, so what the doctor has literally said that there is a 50% chance that everyone is surviving in my things. But then he says that the last 20 patients have all survived. The thing is now people might not want to go to this doctor.
Why?
The reason is because now it's already gone. His streak has so far gone for 20 patients. Like each person has like a chance of like surviving the surgery of 1/2. So if you multiply everything, because the chance that it is a concurrent 20, it will be 1/2 to the power of 20. And now you need to add one more 1/2 to that. So it's the chance that you survive right now will be 1/2 to the power of 21.
Fantastic answer, amazing answer. So let's all give them a huge round of applause. And does someone have another answer? Who hasn't answered? Let's see. Who hasn't answered? Who hasn't answered? There's someone who hasn't answered.
Dhirav.
Okay.
Dhirav, just 1 second. Dhirav, you want to answer?
Yeah, I had the same answer.
Okay, maybe word it in a different fashion. Maybe you want to.
Yeah, so basically what I was about to say was that the chances of because the 20 patients have survived, so the chances of the next person surviving are considerably low because 20 patients have already survived.
Fantastic. Right. So think of it this way. Right. So maybe tying back to what we did in the very start of the session. So let's say the success or the failure of a surgery is now decided by a toss of a coin. Right. So let's say the doctor decides to toss a coin, and if it lands heads, he'll root for the success surgery to be a success. And if the coin lands tails, the doctor will ensure that I know doctors won't do this, but the doctor will say that it's a fail. Okay. Now, what is this saying? This is saying that I already have a streak of 20 heads, right? And now I'm asking for the 21st head also, which is rather unlikely, right? But another point to note is that my tosses are independent, right? But why does this not go well with that? What I mean is my 21st toss should not depend on whatever happened earlier, correct? So why is this in some sense like a contradiction in your own head going on? So on the one hand, you're saying tosses are independent. So whatever happened before should not influence what is going to happen. But on the other hand, you're also saying that I got 20 heads and my 21st should be a tail. Like what is going on? What is going on? I'm too confused now. Does someone want to explain?
Yes, there are already some raised hands. If it is not for this answer, you can just lower your hands. Otherwise, I'll just call out some name from here, probably somebody who hasn't answered. So the Dikshant, you want to go?
Yes, sir. Actually, 1/2, that is half, is the probability of getting the next, and next, that is it is correct. And from where he got 1/2, that was first the doctor got 1/2 from his previous surgeries, maybe. So it is true that means now that you talk about it, I realize that the 21st patient that it is very less chance that the 21st patient will survive. It's not true. It is 50-50.
Okay, good. That's a good answer. So this is a never-ending debate, right? What is actually going on here is a never-ending debate, and so you'll see a lot of this when you properly do a course in probability theory. Why all this happens, right? So this is something one more reason to study probability theory. Awesome. And now let's say I think I'll have questions for time for questions this time. So let's say, okay, so this is again a very common problem. Okay, so all of us face when we're traveling intercity, right? So let's say there are 10 lanes in a toll plaza. Okay, so there's lane 1, lane 2, all the way up to lane 10. You're traveling in a car, there's a toll plaza in front of you. Okay, now what I want to find out is, let's say, how do you internally decide which lane to go into? Any answers? Put your answers in the chat. how do you decide which lane to go into? The least crowded, less traffic, shortest, obviously, right? So the least, you'll not want to go into the toll plaza which has a really long line, 20 buses and 30 cars standing behind you. Don't want to do that, right? The one with the shortest line. But now let's say hypothetically, right? I'll in fact convince you that this is not hypothetical, but what if there were 1,000 lanes? There is fast tag, yes, but you still have to, in some sense, spend a non-zero amount of time in front of this thing to scan, right? So now my question is coming back to the point: what if there were 1,000 lanes? What could be a problem? What could be a problem in deciding which stall lane to go into when there are 1,000 of them? Fantastic, awesome. You can't see all of them, right? So what you should do. So now let's say you have 1,000 lanes. You have to get out of the car, walk through all 1,000, remember which has what length, and you also have to then pick the minimum and then go to it, right? But this is too painful, right? This is going to take a lot of time. You might as well wait behind a lane which is hopefully not too lengthy, right? And this is where a very cute idea of randomness comes in. Do you want to take a guess as to what you could potentially do? Any guesses? Just type it out in the chat for now, and then we'll take up. Randomly pick. Okay. Anything better than randomly pick? Randomly pick is one. The one nearest to you is not quite random. No, I want to bring in some probability. I want to bring in some randomness. The nearest lane with the least crowd. Okay. Yajat, I want you to explain your answer. What do you mean nearest lane with least crowd? So how much are you going to look at? And where are you going to start looking at? Yajat, are you here? You could unmute.
You have to go to the nearest lane which has the least amount of traffic. Means not too far away from.
So where do you start? The nearest. So for nearest, you have to start searching from somewhere, correct? Where
Like
do you
4 or
start
5 lanes on both sides. In that, see which has the most, which has the least traffic.
Awesome. That is good. So you'll start at say fourth or a fifth lane, right? That is nice. Awesome. Say go how much over you can go, but all these are going to take time, right? Awesome answers, right? Now, what I in fact say is that I think one of you said it already, which is it's obviously 1,000 lanes take too long to scan. What I'm saying is that take 2 lanes at random. Okay, let's say I pick, say there are 1,000 lanes. Let's say I pick the 273rd lane and maybe the 784th lane. Okay, 273 and 284. I pick these 2 lanes. Okay, and whichever one has the shorter among these 2, I'll go to that. Okay, that's something interesting to think about, no? Is this making my life any better? I have to ponder over this, right? I don't know if it is in fact making my life better. Yeah, so there is a problem that you may pick the highest 2, right? But the chance that you pick the highest 2 is low, right? So in fact, this works probabilistically. That is, most of the time you'll be lucky, right? Most of the time you'll be lucky, but there is still a teeny tiny chance that you're going to have a really bad day on that day, right? So on other hand, so someone said, Manu suggests pick 5. Awesome. Pick 5 lanes and select the one which has the least. That's an amazing answer, right? So similarly, you can think of something like this. So let's say I have n lanes, okay, 1,000 lanes. I'll pick maybe 10 of them, and 10 is rather easy to scan, right? We scanned 10 in the earlier slide. We scanned 10 lanes and went to the least. So now the 10 I'm choosing is going to be at random. I'm not going to choose something like say everything is adjacent to each other. So that is a possibility of something being random, but I'm for now not including that, right? So I'll take some 10 random lanes out of these 1,000, and I'm going to enter the minimum of these 10, right? And this is in fact proven to have a slightly better, much better, right? Now, I did say that I'll convince you that 1,000 lanes is actually of practical importance, right? So now don't think of it as toll plaza. You're not waiting in a toll plaza anymore. Instead, think of it as, let's say you're a computer, right? You have to assign jobs to a particular server you have, right? Obviously, a server will have thousands of clients, as they are called, and you get queries in and out. You get lots of queries, and you have to decide whom to allow, which client to allot which query to, right? And there are thousands of clients, right? So here what you do is, here is where this is of practical importance. That is, you pick 10 of these at random. You pick 10 of these clients at random, and you allot an incoming query to this particular client that you have. Sorry, this particular allot this query to this minimum, quote unquote, minimum client that you have, right? So I think that's more or less all I have to say, and just some references for you to think about. So the Toll Plaza example, in fact, I stole from this talk by Professor Kavita Ramanan of Brown. So she's given a talk titled "The Tales of Randomness." It's a fantastic talk, and it should be accessible to all of you. So this is something that you should check out, and quite a few other topics are stolen from this legend, Manjunath Krishna. So, and I think I'll rest my pen here. So thanks.
We can take maybe 2 or 3 questions, right?
Sure.
Okay. So those of you have questions, do a raise hand.
Oh, I see one by Siddharth.
Yeah.
I have a question. Okay.
That go ahead.
Excuse me.
Hi. Yeah.
Could you go? You said you had. Could you please go back to the slides? Drug trials. The drug trial.
I did not go through it, but sure.
It was right there.
Yeah. Oh, what about it? I did not. I skipped this section in the interest of time, but.
Oh.
Yeah. Okay.
Vihan?
Yeah, actually, I have a doubt, so I'll just. So, won't we take the most crowded lane? Because if every human just starts thinking like this, that let's take the easiest path will become crowded.
Okay. No, I'm not quite sure I got you. So you're saying you'll pick the crowdest, the lane with the most crowd, and.
Yeah, I'll pick the lane with the most crowd because it's human psychology that everyone will pick the easiest path, right? Seeing it's less crowded, and everyone will just go on the easiest crowded lane. So like the less crowded lane. So because of that, what happens is that lane becomes more crowded. So you would go to the more crowded lane. But this is actually only accurate if there are less number of lanes and more number of people.
So at least from what I can say, you're being a philanthropist and you're being in the most crowded lane so that others can go to the less crowded lanes. But I immediately do not see how say this is.
So if I can interpret, yeah. So I think what he was trying to say is, because everybody would think, like somebody said in the chat, like game theory, because everybody would want to go in the less crowded lane. So everybody would go in the less crowded lane, which will make those lanes more crowded. So I might as well go in the more crowded lane, which probably will eventually become a less crowded lane because everybody else has gone to the more crowded lane. I mean, less crowded lanes. But I think what might be missed out is that it's not that the world is at a pause and then we decide and then we would. So the lanes are getting cleared as well in parallel, right? So yeah.
So in other words, so I think one place that this could be useful. So one problem with this is that there is traffic incoming, right? So there's not a static traffic which there is. So every single minute or every second, the structure of these 10 Toll Plaza lanes is going to change, right? So in this setting, I'm not entirely convinced that this would work. Okay, but maybe this is something interesting to think about. Maybe write to me, and definitely we should. Maybe I'm not entirely understanding your question, but write to me and we can think about it. Okay. So I think there are 2 more raised hands.
Satya?
Yeah, sure.
Yeah. So I had this doubt, like I didn't understand, like why can't you simply just choose a lane which is the farthest away from the path which you are actually moving on?
And how is that going to help?
So like people who like for the first trial, like for example, the first vehicle which enters the toll plaza, if you consider that, they're going to fill those lanes which are not filled completely. So one by one, they are going to fill.
Yes, yes. So if things work uniformly, so let's say there is one single lane coming here. I hope you can see my video, right? So there's one single lane coming here, and let's say it suddenly diverges into 10 lanes, right? In which case, the optimal thing to do would be to the first car goes to the first lane, second car goes to the second lane, third to the third, fourth to the fourth, 10th to the 10th, and 11th to the first, 12th to the second, and so on, right? But the problem is cars are not going to come in a single lane. Right? Cars themselves are going to come in 10 different lanes, and then you have to randomly allocate. So cars are going to move here and there. Correct. In this case, it will be a better idea to not go to the last lane always, because for all you know, the last lane may be the longest. Are you convinced?
Yes, sir. Understood.
Awesome. Okay. That's great. And any other questions?
Yeah, I think most of the, this is also regarding the same toll plaza problem. I think most of the cars will be close to the median of the road. So by on knowing that we are going to go to a toll plaza, we can start moving towards away from the median, so that we go to a we go through something which is not likely.
Fair
It won't
enough.
have much of like.
Fair enough. That is something, but you're bringing in some psychology into it. But this is something which is like, say, completely in when you're picking lanes at random. You're bringing in some psychology. But this is a good suggestion. Yes. And yeah, is there anything?
I have a doubt, sir, that if there were 1,000 lanes in a toll plaza, so and if the traffic was less than 1,000 cars, then it would be like some lanes would go empty, and unless it is a very high, the toll is in a very high tourist place like world famous, there would be at least many cars, and like it would not be that crowded. And on that other hand, we have FASTag now, so it would be really fast.
Correct. But unfortunately, computers don't have FASTag yet. Right?
Yeah,
so
yeah.
computer queries still have to bear through the pain of allotting queries one by one.
Yeah.
Yeah, that's a good question. Yes. And I think one final question maybe.
So, like if you take two lanes randomly, it is expected that one lane will be in the first half, the other lane will be in the second half. Like it will be in the first 500 and the 500 to 1000. So then you will probably pick one of the lower lanes. But then, like if you take four randomly lanes, then one will be in the 1 to 250 and then 250 to 500. That is the expected distribution. That is why this works. For the more the lanes you pick, the higher the accuracy.
The more the lanes you pick, the higher the accuracy of what? I'm confused. Sorry.
The accuracy, like by that I mean that you'll pick a shorter lane.
Cool. Nice. Yes, good. That's good. Nice. That's good. So I think that's more or less all there is. And so if you have any questions, you can definitely write out to me.